Hey makers, welcome back to our 360 Embedded Sphere, your favorite stop for IoT and embedded projects. In today's tutorial, we'll be building a smart IoT environment monitor using ESP32, MQTT, and Node-RED. The ESP32 will collect data from sensors, that's temperature, humidity, altitude, and pressure, and publish them to an MQTT broker. On the other side, Node-RED will visualize this data on a clean dashboard with gauges and let us remotely control devices such as the LEDs and a fan in real time. Let's get started. The components used are ESP32 development board, a DHT11 sensor, BMP180 sensor for pressure and altitude, a relay module 5 volts for fan control, a 12 volt DC fan, 2 LEDs and two 220 ohms resistors, jumper wires, breadboard, and also a high watt 9 volt battery. First, we'll be connecting the DHT11 sensor to the ESP32. First, connect the VCC of the DHT11 to 3.3 volts of the ESP32. Next, we'll be connecting the ground of the DHT11 to the ground of the ESP32. Next, we'll be connecting the data pin of the DHT11 sensor to the GPIO2 pin of the ESP32. We'll be moving on to the BMP180 sensor. We'll be connecting this sensor to ESP32. First, we'll connect the VCC of the BMP180 to 3.3 volts of the ESP32. Next, we're connecting the ground of the BMP180 to the ground of the ESP32. Next, we'll be connecting the SDA pin of the BMP180 to GPIO21 of the ESP32. Connecting the SCL pin of the BMP180 to ESP32 GPIO22 pin. Next, we'll be connecting the relay module to the ESP32. First, connect the in of the relay module to GPIO5 of the ESP32. Next, we're connecting the VCC of the relay module to the V-in of the ESP32. Next, connect the ground of the relay module to the ground of the ESP32. Always connect relay and ESP32 to the same ground for proper switching. Now we'll be connecting the relay module to the DC fan. First, we connect the normally open pin to the positive wire of the DC fan. Next, connect the negative wire of the fan to the ground of the ESP32. We'll connect the 9-volt battery positive pin to the COM pin of the relay module. And now we'll connect the battery negative to the ground of the ESP32. Next, we'll move to connecting the LEDs to the ESP32. To first connect the LED to GPIO4 with 220 ohms resistor. Connect the ground to the ESP32 ground. Next, we connect the second LED to GPIO18 with the 220 ohms resistor. Next, we connect the second LED to GPIO18 of the ESP32 with the 220 ohms resistor. And connect the ground to the ESP32 ground. Let's break down the code step by step. The DHT library is used to read temperature and humidity. The Adafruit BMP085 library is used to read pressure and altitude. The Wi-Fi library connects ESP32 to Wi-Fi, while the PubSub client handles MQTT publish and subscribe. The pin's definition. The LED pin is connected to GPIO4, while the second LED pin is connected to GPIO18. The relay pin is connected to 5, and the DHT pin is connected to GPIO2. Wi-Fi and MQTT setup. ESP32 connects to your Wi-Fi. Data is sent to free public MQTT broker test.mosquitto.org. Important note: ESP32 must have internet access to reach this broker. This callback function is used for receiving MQTT messages. If a message is published on topic ESP/LED, LEDs turn on and off. If a message is published on topic ESP/fan, the fan turns on and off. The reconnect function. If the MQTT connection drops, ESP32 keeps retrying until it reconnects. The sensor data function. This reads temperature, humidity, pressure, and altitude, and returns all values in a struct format. This function here helps to publish the data. It formats reading into JSON, publishes to topic ESP/sensor every 5 seconds, and also this payload is displayed on Node-RED dashboard. After it starts, open a web browser and go to http:// your local host. In the Node-RED, click the menu, then click Manage Palette. Go to Install. Search for Node-RED dashboard. And install it. This adds UI nodes like the gauge, switch, and chart to the sidebar. Now we'll move to adding the MQTT node. Drag an MQTT in node. Double-click to configure. Set the server to test mosquitto.org. The port as 1883. And topic as ESP/sensor. This will receive sensor readings from the ESP32. Then drag two MQTT out nodes. Set their topics as ESP LED for LED control and ESP fan for fan control. So we'll be using a parse JSON payload. This will convert the sensor data from text into usable numbers. To create the dashboard widgets, first for the temperature gauge, drag a gauge node. Double-click. Label it temperature degrees Celsius. Set the range from 0 to 50. The value format should be message.payload.temperature. This connects JSON to temperature gauge. The next gauge will be the humidity gauge. Drag a gauge node, label it humidity %. Set the range from 0 to 100. The value format should be message.payload.humidity. Should do so for the pressure gauge and the altitude gauge. You should do so for the pressure gauge and for the altitude display. Now you drag switches for your LEDs and fans. Label your switch LED control. The on value should be labeled 1 and the off payload value should be 0. This connects switch to your MQTT topic out. This connect switch to your MQTT out. The topic should be labeled ESP LED. Also drag a switch for your fan. Label the switch fan control. Set the same setup, but the difference will just be the topic, which will be ESP/fan. All these are connected to the MQTT out palette. When you are done, you can now deploy and view the dashboard. Click deploy button at the top right. Open the dashboard at http your local host/UI. You will see gauges updating live with sensor data, switches to turn the LEDs on and off, and also to control the fan in real time. At this point, your ESP32 is talking to Node-RED. The dashboard is visualizing live readings, and you can toggle devices instantly. In this project, you have learned how to connect ESP32 to DHT11 and BMP180 sensors using MQTT to send sensor data and receive control commands, and also build an interactive Node-RED dashboard with gauges and switches. All components are available at hub360.com.ng. Like this video if it helped. Subscribe so you don't miss part 2, where we will run our own MQTT broker on Raspberry Pi OS and take full control of the system. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.